So, let us briefly recall what we were doing in the last lecture. So, we were looking at the development process of a database system. So, basically it has these steps that we need to first collect the requirements for the system and then there are two kinds of requirements. I was that first thing is that we need to figure out what are the important entities and associations between them that we need to represent, and then tell us about the various operations that need to be performed as part of the running the enterprise. Okay, so these requirements need to be collected and then we convert this into a representational level data model, which is this relational data model, and choose the RDBMS. Choose means, so there are lots of providers of RDBMS right now, Oracle, DB2 and Microsoft SQL Server, so many RDBMS systems are there. So, we can choose one of them and then create the database and convert these functional requirements that we were talking about into what are called application programs. So, these are programs in high level language that use SQL in order to interact with the database system and modify the database system as per requirements of this functionality of the enterprise. The day to day operations of the enterprise are captured by these functional requirements. Okay. So, so in this lecture we will focus a lot on the various subsystems of a database management system. Okay. It is as I was telling you, the RDBMS is a pretty complex piece of software and it has lots of these components, lots of various so we will look at each of these components a little bit in detail. In some sense this picture that I am going to show here gives you a complete kind of introduction to this entire course, because this has the various components of this particular system architecture are going to be covered in various modules of this course, and so this kind of gives you a complete introduction to the entire set of the entire set of modules that are going to come up in this course. Okay. Now, there are various things in this picture. Is this picture clear, visible? Okay. At this place, we have a picture that shows a disk. So, this is the disk storage. So, this is where ultimately the database and all its related information is going to be stored. In fact, there can be several databases that will be stored. So, we can roughly divide that into metadata, data and log. We will talk about log a little while later. Basically, metadata is the schema information about the database system, all the structure information, the names of relations, names of attributes, their data types, other constraints that they are required to satisfy. All that information is this metadata, and then we have actual data that will be the various tuple instances that are there as part of the relations, all actual pieces of data, names, roll numbers and things like that, all those phone numbers, etc., all the various pieces of data. So that is the data, and then we also have log. We will talk about it a little later. Now, at this end, let's focus here. First, we will try to understand as to how the system, a particular database system will be set up, and then how it will be used. Right. So, we will first focus on how to set it up. In order to set it up, just now we looked at the steps involved in setting up a database system, right. So, after the first step, we have all the requirements in our hands, and typically these requirements are going to be represented in a high level conceptual level model like an ER diagram, and then we sit with the stakeholders, engage them in a discussion and explain clearly the requirements as we have understood from the discussions and get a go ahead from the stakeholders. This is a very important step, because we need to have the clarity about the requirements before we proceed to build the system. If there is some ambiguity in the requirements and we have not been able to have a clear discussion and convey what we have understood about their requirements, and if there is some misunderstanding at this stage, then it is likely to affect the design of the entire information system, and then might actually cause a lot of problems later on when we build the system. So, for any engineering enterprise, design is a very important thing, right. So, at the design stage, we must pay a lot of attention and then engage with the end user and get clarity into the whole process and clearly convey what we have understood and whether they have understood what we have understood clearly, and all this we should ensure and get a go ahead from the end users. And once we do that, we typically convert the information that we have gathered into the representational data model, as I was just now telling, which is the relational data model. Of course, once we convert that into relational data model, the RDBMS will come into the picture. So, RDBMS, as you all know, provides you or implements the SQL standard. So, implements the SQL standard. So, SQL provides you what are called commands that are DDL commands, data definition sublanguage, or we do not this is part of SQL itself. Earlier it used to be called data definition sublanguage. So, basically there are statements like you would be already heard about these statements like create table is a command using which you actually create the relation, etc. So, these are the kind of commands that are part of the DDL sublanguage, part of the SQL standard, and using that we will actually set up the skeletal structure of the relational database system. So, all the relations that need to be present will all be designed, and then so there is a DDL and command processor that will take up these set of SQL commands that will create the relational structure and convert that into low level details, and then actually set up the required information structures back in the disk. So, you can see that the RDBMS has a compiler in it. So, it has to understand SQL, right. So, there is an SQL compiler that has to be part of the RDBMS system, and SQL statements will be converted internally into has to be processed, and they have to be converted into appropriate information structures on the disk. Okay, so that is the who does this? It is the database administrators. The database administrator will set up this skeletal structure of the database, and then we will see how the database will get used. Okay. So, right now there is not any data in the database, just the structure as to what are all the tables are kind of empty. but we have all the table structures and the constraints that need to be satisfied by these columns and these details are all in place. We will of course later study in detail as to how exactly these commands look like. Okay. Now let us go to the top portion of this picture here. The typical use of the information systems that you would have encountered when you interact with various systems in the real world is that there are people who will gather some important pieces of information from us and then interact with the information system and provide some service for us. Like for example, when you go to the library, they will ask you, okay, where is your ID card and what is the book that you want to borrow. Okay, these are the two pieces of information they will ask, and then they will key in this information and then say that okay, yes, this issue, this particular the fact that this book has been issued to you is now recorded, and so you can take this book, right. So what they are essentially doing here is use the information system, but then they are interacting with that through a graphical user interface, feeding some parameter values and invoking some program inside that. Okay. So these programs are what I have just now told you as these are the ones that are called as application programs. The application programs are the ones that kind of provide all the functionality that is required for the day-to-day operations of the enterprise. Okay. So if you focus on library again, so the various operations that it is involved on a day-to-day basis would be enrolling users, issuing books, recording returns, collecting fines, procuring books, recording that a book has arrived, etc. So these are the various things, right. So for each of these things, there is going to be a high level program that will be written, and it is written in either C, Java, C++, etc. And as part of that program, it will somehow invoke SQL and interact with the database in order to send those in pieces of information that it has collected to the database. Okay. So that is why application programs go through an application program compiler. So now these application programs have SQL inside it, right. So obviously it has to be pre-processed so that you can remove all the SQL commands from it and then send the remaining program to the usual C compiler or C++ compiler. Let's stick to one language, let's say C, and then the program has to be compiled. But then there are these embedded SQL commands. So obviously these SQL has to be replaced by appropriate function calls so that the program becomes complete, right. So these function, who provides the function, the RDBMS vendor would have provided these implemented function interface, and these functions have to be then used, and then the program has to be compiled into an executable thing. Okay. So the application program developers, they are called application programmers. The application programmers would use a high level language like C and use SQL and submit that thing as a application program. But then the RDBMS system has to use a normal C compiler, and then the functions that have been provided by the RDBMS. So RDBMS vendors would supply these library functions that will be useful for implementing these SQL commands that are used inside the host language programs. So, so together this will be compiled into a compiled application program, and you keep them in store, in so to say. Okay. So, these are also kind of stored inside on the disk as stored programs, right. So, when these people behind the counters are operating, what they are essentially doing is invoking one of these application programs and supply the parameters to them. So, we will use them, so we will so we can probably even call them as parametric users. So, they basically use the system by simply supplying the parameters. They probably do not have a full idea about what the system, how the system actually works and things like that. They do not need to actually. These are the people who are operating the system. Okay. So, when they do that, this compiled application programs have to be taken up by this RDBMS runtime system, and it has to actually run the required SQL functions through this backend, and then ensure that the data on the disk changes appropriately, right. So, all that is involved in this particular chain of activity. Now, okay, let us now look at, we will probably come back to this again, but let us look at this. What is this? This is apart from the commands that are put inside an application programs, usually the database system will have another interface through which we can write and submit, through which we can submit SQL commands, SQL queries. Like for example, you might suddenly let us say we are how many number of computer science books have been issued out in the last 1 month, somebody wants to know. Okay. And so, this SQL later we will see will provide you the appropriate language means to translate this into a query, and that SQL query will have to be managed by the, I mean it will have to be put through a query compiler and then appropriately run on the data, so that we get the results back and then give them the results to the analyst that who is analyzing as to the usage of the database, how okay. Now, here is another interesting thing. SQL, as we will later see, is a declarative language, is a largely declarative language. So, what do we mean by declarative language is that it gives you a way of specifying what you want without actually telling how that information has to be obtained. Okay. It gives us such a kind of a mechanism, so that you can specify what is the information that you want from the information from the database system, without exactly specifying how that information has to be actually put together from the database. That information that you are looking for might be actually lying in multiple relations, multiple files and things like that. So, those are lower level, those are other details, but SQL gives you a way of indicating as to how indicating what exactly is required without telling how it has to be obtained. Now, the how part of obviously is important. So, what exactly happens internally is that SQL queries will be converted into what are called relational algebraic expressions. They will be converted internally into relational algebraic expressions. So, we will, when we go to the relational data model, we will study what this relational algebra is all about, but at this stage we can just understand that it is something like a arithmetic expression. We have a algebraic, relational algebraic expression, and when you execute the relational algebraic expression, we will get the results that we are looking for. Okay. Now, the reason why we actually use relational algebraic representation for the queries is that once we have a algebraic expression, just like an arithmetic expression can be executed in multiple ways, right. If you have a bunch of arithmetic operators and then there is a arithmetic expression, you can imagine that there are multiple ways of actually evaluating that, right. You might evaluate this operator first, then probably operate a sub expression later first, and then etc. There are multiple orders in which you can evaluate the expression. In a similar way, once you convert this into a relational algebraic expression, there will be multiple ways of executing that, and some of them will be fast, some of them will be slow and things like that. And so, there is an opportunity for us to look at these possibilities of running that, evaluating that expression and optimize the expression in such a way that we will use as small amount of time as possible to actually get the information. So, the query optimizer module that is there here essentially contributes to this activity, that it will focus on this relational algebra expressions that are coming as a result of these SQL queries that are being submitted here, and then it will see whether there is an opportunity for improving the what is the plan in using which we can run that particular query, and then it will give it as to that particular method to the runtime system, so that it can actually run the query in that particular way using the data in the database and then give back the results. Okay. So, that is so we are going to focus, we are going to study this relational algebra, and then how exactly these relational algebraic operations are actually implemented by the RDBMS runtime system, etc., later on in the course. Okay. Now, any questions? So, we looked at in this picture, we looked at the how the database is first set up and how queries can be run on the database, right, and then what are these application programs. Application programs are to be compiled into compiled application programs and then stored, so that they can be repeatedly invoked to carry out the day-to-day operations of the enterprise. Now, since we are repeatedly invoking these programs, we have to be very, very careful about how these programs run. They should run correctly and they should run efficiently. So, a thorough testing of these application programs is essential before we adopt them as correct application programs. Now, what you can see here is that once the database has been set up, it is through these repeated invocations of these compiled application programs that data actually gets accumulated into the database, right. So, for example, as I was telling you about the library information system. So, as day to day operations keep happening, a lot of lot of data about who has issued what book, and what book is inside the library, what book is not there in the library, all that will now get started getting recorded into the database here, and it currently reflects the current state of the affairs of the library, right. Okay. Now, let us go a little bit more into this other parts of the database management system. Now, in order to understand this is transaction manager. So, it is just written as trans manager, but it is transaction manager. I gave a brief idea about transactions earlier, but essentially a transaction is a logical unit of work that has to be done in its entirety. Okay. So, the nature of that work is such that you either do it completely or do not do it at all. That is what we want. That is what we say as a logical unit. So, you have to kind of think of the whole thing as one atomic operation. It has to be either done completely or do not do it. For example, this is best explained using the example of a bank. So, if you are transferring 1000 rupees from A's account to the B's account, it has to be done in its entirety. You cannot reduce 1000 rupees from A's account and not credit it to the B's account, right. It has to be done, otherwise A would end up losing money and B would not get the money, the transaction is not complete, right. So, such kind of units are what are called transactions. Now, it is very important for the database to recognize these operations as atomic pieces of operations and ensure that they are run in their entirety. Now, of course, in practice these programs have multiple steps inside them. First, you have to check whether A's account has at least 1000 rupees or more, I mean at least does it have the required amount, and then you have to reduce 1000 rupees from that fellow's balance and then update the balance, and then open whatever B's account and add it and then store it as B's balance, etc. There are multiple steps involved in this, and a database actually might fail. The system that is operating this whole programs might fail any time, but then the RDBMS takes the responsibility, saying that these pieces of these things that you declare as transactions will be run in their entirety. So, in order to do this, the RDBMS has to take certain measures internally, so that in case a system failure occurs, some transaction which has just been partially done, okay, would not have been recorded in the database. So, it has to take measures like that. If a transaction has been partially completed, then its effect is not there in the database that is sitting on the disk. Okay. And if some transaction has completely run and you have from your side you have given a go ahead saying that yes, I have done the transfer, then whatever the required changes have to be permanently recorded in the database, right. So, all this the database has to ensure. So, in order to do that, it uses what is called a log. Okay. A log is some system, we will again have to go into the details later on. There are multiple kinds of logs that one can maintain. it is essentially a system where information about the updates that are being done to the database are recorded in a separate place, so that when there is some issue of this kind where you have to either undo the operations of certain transactions or etcetera, it can be done making use of this information that is stored in the log. Okay. So, log is a some kind of a mechanism, or in fact it is a file where we will store appropriate information about the running of the transactions, so that when there is a situation of this kind where some failure has occurred and we have to come to bring the database to a consistent state, information from the log can be made use of. So, it is the recovery manager that comes into the picture when there is when there is some kind of a crash in the system. A recovery manager is the one that gets the control of the database system after it recovers from a crash. A crash might occur, a power might go or a disk might fail, or so you may have to stop the operations of the database suddenly. So, at that time, once you have restored the situation, the recovery manager is the one that gets control first from, I mean it is the first one that gets the control of the whole system, and what it does is to basically check as to what was the situation of the database system at the time of crash and what was the information that was stored on the log, and taking all these things into consideration, it will bring the database system to a consistent state, so that its normal operations can be resumed. Okay. So, that is the role of a recovery manager. Now, we also have what is called a buffer manager here. The reason is that though the entire data is actually stored on the disk, right, and the data is actually stored on files as files. All right. So, the RDBMS will require to update parts of these files to reflect whatever it is doing. So, it has to keep on requesting chunks of the files from the disk. So, there is a buffer manager which will buffer the information on memory and then keep providing. So, you will some of you might have done the operating systems course. So, you have studied this paging mechanism, right, paging while dealing with the disk systems. The disk systems are slow, and so you want to store chunks of the files into the main memory, so that operations in the main memory can carry on. But then as operations update, as the memory operations happen, and then these information is updated, it has to be stored back into the database, right. So, this is how so it is in that context we will get what is called a buffer manager. Now, this is very interesting to see that the RDBMS has to play some part of the operating system's role, because it has to basically implement this paging mechanism there. Okay. And we will later on study as to why it cannot really rely on the operating system in order to do this paging mechanism. It has to have, it really needs to have a tighter control on how information flows from the memory buffers to the disk buffers, to the disk. We will study it as part of this transaction management and recovery module. Good. So, I suppose you got a fair picture of what are the various subsystems that are involved in a RDBMS system. Now, whatever I have been talking about is there in the next few slides, like what is disk is storing, and then what is the DDL SQL command processor will do. It creates the relation schema and the constraints. It also handles authorization and data access control. The query compiler compiles SQL queries and also update delete commands. The query optimizer selects a optimal plan for executing a query. As I was telling you, the query is represented as a relational algebraic expression. Then there is the application program compiler that preprocesses the application programs, uses the host language compiler, and also integrates the compiled program with the libraries of the SQL supplied by the RDBMS. And the runtime system executes the compiled queries and the compiled application programs, etc. The transaction manager keeps track of, interacts with the runtime system, it keeps track of the start end of each of these units of work, the transactions, and it enforces what is called concurrency control protocols. We will study them later in detail later. Basically what it stands for is that when multiple transactions are submitted to the RDBMS system, they have to be concurrently processed, but the database has to ensure that at any point of time the database is in a consistent state. Then the buffer manager manages the disk space, kind of implements the mechanism, paging mechanism. The recovery manager, as I was telling you, takes control as after the restart of the system after a failure, and brings the system to a consistent state before it can be used for normal operations. Okay. Now, let us briefly look at the various people that are involved. What are the roles for people here? Okay. So, there are these naive users or database data entry operators. I was telling these are also, so they basically use the GUI provided by the application programs, feed in the data and invoke an operation. So, these are the people whom we encounter at the train reservation counters or the library issue return counter, etc. They invoke the application programs. They do not need to have deep knowledge of the information system. They only have to know how to invoke these application programs. Then we have application programmers who have to be thoroughly knowledgeable about the logical schema of the entire database, and then they are the ones that are responsible for translating the functional requirements of the database into application programs. So, they have to use high level language and develop programs to handle functional requirements, and meticulous testing of these programs is absolutely necessary, because they will be repeatedly made use of. Then there is the sophisticated users or data analysts who have a good idea about, complete idea about what is the database structure is. They use SQL to generate answers for the complex queries. And then we have the database administrator, the DBA is also called database DBA. DBA is responsible for designing this logical scheme, creating the structure of the entire database, monitor its usage, and if necessary do some performance tuning by creating necessary index structures to speed up some application programs. And this person is also is very important in the sense that he or she would grant in or revoke data access permissions for all the other users in the. So, this has to be the very trustworthy person, because he has complete control of the entire database. So, these are the various roles that people play in the information systems. Good. So, with this we have come to the end of the introduction module of this particular course. Here are the set of books that you can use. These slides of course will be available to you, so that you can look it up later also. It is kind of interesting to assume to observe that in the 3 of the 4 books we have an Indian author. Shyamkant Nawate is from Georgia Tech, Raghuram Krishnan used to be at Wisconsin, Sudarshan is at IIT Bombay. So, all these books are available. The last book is also available as all of them as available as Indian editions. So, while we are talking about the various concepts in the class, I urge you to keep reading the books. Okay. So, with that we will stop here.